Okay, where to start? Where to start? Maybe the beginning. All right, I'm gonna just go ahead and show some slides in this window that might start us out. I'll probably do some demos as well. Let's see where we get. So KUDO, what is it? First of all, it's useful to know that I'm Ken. I'm used to doing this presentation in a couple of places, so I don't know if we normally do that here, but I'm one of the application developers. I'm actually one of the committers on KUDO and KUDO. So if you have any deep questions, that would be, I'm also co-chair to the Operator SDK community meeting. So I'm kind of involved in the operator space of Kubernetes. And we can get into that. We can get into what that means. It's always great in the open source space in general. You know, there's a couple of ways that we get rewarded, but one of them is through accolades, and this is the crew that has contributed so far to KUDO in some fashion. So and they're not in any particular order, I don't imagine. But Jared, if he's on there somewhere, I don't know. Yeah, at the very bottom. Jared and Elena at the bottom also are leads on KUDO itself. I'm taking over the lead on KUDO. And I'll show a little bit of KUDO in this presentation too. We're going to focus on KUDO and what that is, but I saw value in potentially sharing a little bit of KUDO as well. So what is this KUDO thing? So first of all, it is the Kubernetes Universal Declarative Operator, and the primary focus with that is declarative. There's a number of people trying to approach operators. The term operator is worth reviewing for a second. In 2016, the end of it, 2016, it was December, there was a great presentation put together from CoreOS, and they basically defined what an operator is. And it's loose enough that it can be a little bit confusing to folks, right? When I say it's loose, it's like, usually people attribute CRDs, custom resource definitions, and controllers, and somewhere in between, or maybe the combination of those two things, provides what an operator is. I like to think of an operator as, first of all, maybe we should talk about what a controller is, right? A controller is a control loop, a program that is running in a control loop, just this loop that is checking the state of Kubernetes, checking the goal of what that controller is responsible for, and then taking action if the goals don't match the current state. That's what a controller is. And those controllers pretty much run and schedule everything within Kubernetes. We have the replicate controller, we have a node controller, so if you have the node controller, its entire job is just managing nodes and understanding what they do. Now, where does this operator play in? What is the value of that? Well, in the early days of Kubernetes, we just had controllers for stateless operations, and stateless operations are easy. There's not a whole lot to them. If you have a DNS or name service, it stands up, it has some state. Usually it's in some kind of storage, and as long as it can acquire that information, we're good. If it's missing that information, it can go to some authority and acquire that information. So there's a built into the protocols ways to manage that. So what is this operator? Well, let's move forward and we'll see if we can help define some of that. So KUDO, what's the focus? We have this building out Kubernetes operators, and to do that, in other words, to build a controller, let's just stick with that term for a second and we'll move forward with that. When we're building a controller, it can take a lot of code. It can, like most people, if you want to do it from scratch, would use maybe controller runtime. You might go out to client Go. Now, what we're talking about, generally speaking, is Kubernetes is a RESTful API with JSON communication protocols. Internally, it's protobuf, but from a CRD standpoint, it's JSON. So you could use any language you want, but historically speaking, so far, the dominant operators are all written in Go. So that's not a requirement, but generally speaking, that's true. And we can get into tens of thousands of lines of code, which is quite a bit. So we took a look at this and said, well, how can we improve the ecosystem? And that led us to be a little bit more declarative. And by doing that, we knew that we wouldn't solve all the cases, right? But what we wanted to do was hit the 80% of the cases. And so that's our focus. It's about manifest scripts, it's about YAML, and it's about creating control around that, and maybe some bash scripts as well, all cobbled together to create an operator. This says what I just said, so you'll have access to the slides if you later on. I'm not sure how we'll do that, but we'll make sure that you get it. So, at the core of what Kudo is, like functionally, what if you could touch stuff, what would it be? Well, first, it's a CLI. We have a command line that is a plugin actually to kubectl. So it's hooked in that way. You can actually go to kubectl crew and install it, or you could use brew to install it. We have a number of different ways. Of course, you can build it. It's all open source. So that's one aspect of it. We have control of operators through a common CLI. We have this manager. So we have a manager, and in this case, it almost feels like meta-controller. There's a controller that's running in the cluster, and its job is to manage things, and that's the mechanism by which Kudo runs. Is that under the Kudo system namespace, we have a manager, and that manager essentially is a controller that manages these details. And then we have a toolkit that accelerates development. So we have two different personas that we're dealing with. One persona is someone who's wanting to create an operator. So we would refer to that as an operator developer. But then we have another person who's responsible for installing the operator, or maybe even using the operator. And that could actually be two different personas, but generally we group them as one. So one is developing it and tooling for supporting that development. The other one is installing and using it, which of course can be broken down into some subcategories. Your choices today to build out a controller and operator pretty much in the Go space fall into these three camps. So we have Operator SDK, we have KubeBuilder, and we have Kudo. To take you through the line here, what you see on the very far left is essentially you're going to write all your own Go code. You're going to use Go libraries to accelerate things, if you will. But you have the most amount of control, but you have the most amount of responsibility. So this can lead to thousands of lines of code, usually in the tens or hundreds of thousands of lines of code. Of course, it depends on what you're doing. You have KubeBuilder, and what KubeBuilder is this ability to script, essentially build up scaffolding, if you will. If you're familiar, it's easy to compare KubeBuilder to something like Ruby on Rails, where you say, hey, I want a controller, and then it will create scaffolding for you and essentially leave comments to say, fill in the blanks here. That's what happens with KubeBuilder. And the value there is that if we had 100,000 lines of code on the left with the Operator SDK, in the KubeBuilder, a bunch of it is already managed for you within a defined best practices, if you will, within certain libraries that reduce the amount of code that you need to do. And so then you're at thousands of lines of code instead. I don't know if the orders of magnitude are exact, but you get the point. There's less code to do roughly the same thing. You're kind of stuck within the opinion of what KubeBuilder is wanting you to do. You can get out of that. I mean, you're still in Go code. You could vary if you will, if you want. It's worth pointing out that those two projects, the Operator SDK and the KubeBuilder, their repositories are combining. They're consolidating. So there's a bunch of code that they evaluated and said, well, we're basically doing similar things at the low levels. We should combine efforts. So Operator SDK and KubeBuilder within the next month should be all in one same repository. They're actually there now. It's just not ready to be managed that way. You're still going to see two efforts, though. You're still going to see Operator SDK. You're still going to see KubeBuilder. Both of those run. If you go up the tech stack, you'll see they all run under controller runtime. And then on the right, we have Kudo. So Kudo is, if you have tens of thousands of lines of code and then thousands of lines of code, then we have hundreds of lines of code, right? So it's less code, and almost always it's declarative in nature or some kind of scripts in that form. It's about using the manifest files that we're already used to knowing and understanding. The other aspect that I would say is this, that we have a hyper focus on day two. We're D2IQ, that's the whole point. So we're focused on day two operators. So this is like, if you're just trying to install an operator, that's day one. That's also fairly easy. The hard part gets into doing things like, how do I manage upgrades? How do I manage metrics? How do I manage a number of things. The other thing that I'm a little concerned with is that we're seeing a growth in usage of operators or controllers. People are just totally customizing their Kubernetes environment in some cases. And the problem that we're going to run into, if we haven't already, is each choice of operator. Let's say I'm going to use the Cassandra operator, and then I'm going to use the MongoDB operator, and I'm going to use, and just start picking. So let's say you have 100 of them. They all have different ways of working with them. They all have different metrics. They all have different ways of doing backups, if they do backups at all. They all have, it's all going to be essentially confusing. I would also add that in the repository, meaning the operator hub, or the, from a CNCF standpoint, the artifact hub, there's mixed bag of maturity models. Some operators are awesome. Some operators are less on the maturity model, to be kind. Right? So that's what we're seeing. And so one of the things that KUDO does, well, a couple of the things that KUDO does. First, it provides a level of abstraction from the KUDO version, from the Kubernetes version. So if you have, let's say, someone who wants to build an operator for Cassandra, not only do they have to be an expert at Cassandra, but they also have to be an expert at Go or whatever language they decide to create the operator in. They also have to know whatever's going on in Kubernetes world as changes come about. So we just went from CRDs, we went from CRDs V1 Beta 1, and we recently released V1, and shortly, within the next couple of versions, we will, V1 Beta 1's been deprecated, but it'll literally be removed in the next version or two of Kubernetes. So keeping up with that is really hard. That's part of our focus, is let's abstract you from that. Let's manage that for you. So that's part of our goal, is that. And as you know, or hopefully know, Kubernetes has a pretty high cadence. Keeping up with something that's going to change. The last review I did is there are 4 major releases of Kubernetes every year, and the release cadence is every 6 weeks, right? So just be aware that there's a lot to take on as soon as you get into the Kubernetes space. Any questions so far? Maybe I'll open up to questions before I continue. Okay, that's the core of what KUDO is it's about building operators, it's about building them declaratively, it's about reducing your responsibility, if you will, and it's about unification, about unifying the APIs, if you will, unifying certain disciplines that we would consider day 2 disciplines, like how do I back up, how do I restore, how do I provide sharding, things of that nature. So. What I haven't probably done justice to quite yet is operators and my distinction. So for me, operators are geared around domains. And the simplest way for me to explain this is I was the author for the HDFS framework on top of Mesos. And if we were to use that as an example, hopefully that would resonate with people. So in order to stand up or provision HDFS, there's a series of things that have to happen. The first is that you have to stand up, assuming production level type stuff, right? Not just play, but I really need something and I need the redundancy that HDFS provides. First, I need to stand up at least 3 journal nodes, and you would want to install those across fault domains. So some operator, some person, some human needs to know what that means and what that represents, or I have to describe that in some way. After those are landed and healthy, so that's step 1, I need to land a name node, and it depends here on scale, but the ideal configuration is that you would land it on the same node as one of the journal nodes. So you need to reserve enough space on one of the nodes that the journal node lands on, such that I can land a name node. And it's not required, but it increases the value of scale. So once I have name node 1 installed, I need to format it, and then I need to stand up name node 2, and then I need to bootstrap it, and I bootstrap it off of name node 1. As soon as all of that is healthy, I can start landing data nodes, and those can land anywhere. And one assumes that you probably want to consider fault domains as part of that evaluation as well. And fault domains, again, depends on-prem or cloud as to what that means, but it could mean cross, it could be a node, it could be cross region, it could be across zones, it could be across a number of things. So whatever that means to you, within your environment, across rack if you're on-prem. So that was a long story. If you were to go to, let's say, Helm in the Kubernetes space, and you found an HDFS for an installation, it's kind of a shotgun approach. It is like install, you know, and then hopefully magic, cross your fingers and wait 30 minutes and hopefully it's running. And it's not something you could, I can't imagine you using it for production. It's neat that it exists. It's great for certain applications. It's not something you could use for production environment. So what could we do instead? Well, we need something that will manage those concerns, something that it is essentially orchestration on top of orchestration. It is the thing that, because all I did was describe what happens when I provision something. What I didn't go through is what happens when I have failures, and what happens when I have failures while I'm still provisioning. All of that needs to be taken into consideration to have a real mature environment that is in some way self-healing, potentially, or at least aware enough to do the right thing under the right conditions. So those are the things that I would say are about, that's what operators are about. Operators are about providing domain expertise, meaning specifically towards a domain. What does HDFS do? What does Cassandra do? When I have Cassandra and I need to reshard something, how do I distribute that? How do I manage that? When I have a slice go down, how can I manage that? So those are the kinds of things. You need some intelligence built into the system. And when you're building stateless applications, we never needed that. So that's why you see operators and stateful needs and operators kind of go together. It's not the only thing, it's just the obvious thing. One could consider potentially that you have a microservice-based architecture that needs to be handled the same way, that you want to build an operator that intelligently manages the orchestration and potentially provisioning and repair of your infrastructure, or maybe above that infrastructure, an application. So that's the core of it. So that was a lot. KUDO architecture. We have essentially we have CRDs, that we have a KUDO controller. It interfaces with the APIs, and of course then writes things to etcd as far as its storage goes. It's just a standard controller. If you know anything about controllers, all control communication goes through the API server, and the API server fronts everything that is stored in etcd. So the main core concept within KUDO that's worth understanding is that we built in this, if you want to call it a pipeline, we built this way of managing this orchestration. So we call it a plan. The plan has phases. The phases have steps, and technically the steps have tasks underneath of it. So a plan, what is that? Well, we have a deployment plan by default for most of our operators, and it does the deployment phase or the provisioning. We have different phases. The reason why you might have a given phase, it's really loose at that point. You have to decide what that phase is. What's the benefit of that phase? How do you know that phase is complete? In the example I gave with HDFS, one could describe name nodes as a phase. And so once we have all three name nodes healthily deployed, that's the end of that phase. Phases can have multiple phases, of course, and those can run either serially or concurrently. And then the assumption then is that within a phase you have steps. Those steps, again, could run concurrently or serially. It's very common to see those serially. Again, that you have full control over that. And at the end of the day, we're applying YAML. So you see templates. We were using Customize, so this is not the case today, but we do have templating capabilities to be able to customize different aspects of KUDO. You know, it might be easier at this point to actually show some demoing. So let's see what I have. Hello, there we go. That's probably small. Is that readable? Get a thumbs up from somebody?
I can see it.
Thank you. Oh, okay. So I'm going to do a couple things here. I will do a demo, but I'm bringing over my VS Code that is looking at our operator repository. So there's a number of operators. We have Kafka, we have Flink, we have RabbitMQ, a variety of things. I'm going to look at Oh, you know what? Maybe it's worth looking just our first operator. It's really just meant as a demo. So that's the name of it. This is the operator, and here's the structure we would expect. We have an operator YAML. The operator YAML has some kind of structure. It's really the metadata. No templating should ever go into the operator YAML itself. It has the listing of tasks, versions that it expects to be successful with, and the plans. So in this case, it's super simple. We have one plan, which happens to be the deployment plan. You can see that it's serial and it's just one phase and one step. So it's fairly simple. We have parameters. So there's also now a way of managing parameters and having values that are controllable. And more importantly, they're versionable. So I can apply some kind of data, if you will, some kind of controls over it. For like Cassandra, how many data nodes do you want? How big should each node be? That kind of thing. And then of course, under the templates, this is the simplest one, but we have a file, and those names can be anything you want. Those are registered within the operator's file itself, which then defines the thing that you're doing. So the struggle with showing the first operator is that it's one, fairly simple, and two, pretty much looks like Helm at this point. I mean, you're just installing something. It just is deployments, but we have a lot more capacity beyond that. That's the core of it. So that hopefully gives a highlight of what an operator is, how I might build one, and the fact that within Kudo, it's declarative in nature. I'm gonna pause again for any kind of thoughts or questions. Make sure that I'm maintaining people's interest. No? All right. So I'm going to show off a couple of things here. One of the things that I also wanted to talk about is this thing that was originally built into Kudo that I've ripped out and created its own repository called Kuddle. Now, Kuddle is K-U-T-T-L, and Kuddle is the Kubernetes test tool. And just like Kudo, it is completely declarative in nature. So I just managed a pull request. I newly added a new Kuddle test specifically for Spark. So why don't we take a look at that? Let's see here, Spark tests. So this should look familiar to you. When we actually write tests for Kudo, and I want to emphasize, Kuddle is about testing anything in Kubernetes. We use it for operator testing. I will also advertise that I've been working with the Operator SDK team. They have a scorecard or testing tool called Scorecard for Operator SDK operators, and we've just newly integrated Kuddle into that as well. So Kuddle will be pretty much the test tool for all operators shortly, I think. And the beauty of it is, I'm just looking at a YAML file. What we're saying is this will assert to be true. And as long as we can find a pod with this name within this namespace, we can be brief. So normally a manifest file would have a crazy amount of information, but the only thing we care about is that this controller, which is the Kudo controller, is running in my ecosystem, and it has reached the status of phase running. So that is the very first check. You can see a 0, 0 here. It's going to be the first thing. So we don't even run anything else unless we can pass that test. So the next step would be, we need to create a namespace called Spark. That's just the demo of what we're doing here. So there's then an assert to make sure that that exists. Fairly simple again. The problem with namespaces, of course, is that once you've created them and if you immediately try to use them, they are not available yet. There are certain things that take time. They're eventually there, right? And this is what we have with eventual consistency. Timeouts within Kuddle are completely configurable. You'll see that here shortly as well. We're going to install Spark. So the great thing about this is I'm actually, in this case, instead of using a YAML, which would be possible when trying to install the Spark Kudo operator, I'm just going to use the command that we would normally use. You can see it fully declared here. So line 4 is exactly what I would expect somebody who, I've lost control of my keyboard. But we do a kubectl, Kudo, install Spark, namespace Spark, and instance equals Spark. That last portion there, the thing that's highlighted on screen right now, just controls the naming of the operator. The default would have been Spark-operator. And to shorten it even further, I just define it as just Spark. So this is us installing it. So why don't we get started? What does this test require of us? The first thing that requires of us is that we have kind running. So I don't know if I have that running yet. I don't. So we'll just takes a few seconds. I am open to questions though while we pause.
I have a quick question.
Yeah, please.
If you go back to your list of tests,
yeah,
these are just run. I guess these are just run sequentially because I see a couple of 1s and a couple of 2s and a couple of 3s. So they're just run like as they're sorted.
That is correct. There's a couple of things to note here. I have a whole presentation just on Cuddle, and I didn't mean to take that over. I just knew that this is one of my hotspots and also a huge value, and I thought I could combine it while talking about Kudo. But
no, this looks very interesting. So yeah.
Yeah. And if you look at what Kubernetes does, there are a lot of their asserts. If you look in their repo, are Bash scripts type asserts, and they're I'm grateful they exist. I really am, but we could do better, and hopefully this is it. So yeah, these run in a sequential order. Asserts always happen last. So anything you see with a name, like you see a 0-1 with a create namespace, and then the 0-1 with an assert, you could have multiple 0-1s. They will all be applied. You can have multiple manifests within one file if you wanted to. All asserts happen secondary. And the style that I tend to write them is I do something and then assert that thing to be true. I could assert multiple things. I think maybe I might have an example of that. I'm not sure. Yeah, so here's an assert, and I'm asserting 3 things at once. We're going to go through running Spark, but when we run a Spark job, this changes the timeout to be very long. It can take a while for Spark to run. And this says that the Spark application, which we're applying, will reach a point where it's at a completed state. That way we know the Spark job has completed. But I'm also confirming that from the Kubernetes event bus, that I've have a reason for the Spark application completed that came out of Kubernetes events. So again, I have deep capabilities of Cuddle or verification with Cuddle. Yeah. Did I answer that question? You went mute, so I'm going to assume you did. I'm currently thinking, man, Ken, you killed it. Okay.
Sorry, I was on mute. Sorry.
Yeah,
I got it.
I answered for you. It was great.
Yeah, no, I got it.
All right, cool. Okay, so what we have kind running. This could be any cluster, right? I could have done a Convoy up and brought Convoy service up. It could be out in the cloud. It could be anywhere. By the way, we do have users of Cuddle running up against GCE and against Amazon. So we are cloud centric as well. So what do we need to do? We need to install KUDO. We haven't even installed that yet. So I am going to say cube Cuddle KUDO oh, it's not going to be there. All right. Well, now you're going to see me struggle, which is fine. This is good. I'm going to do init and help, right? So we have a command line for this. The thing that I was struggling with is I never really want to type this by hand. In fact, let me type the whole thing here, or copy the whole thing. So KUDO does require that there's a cert manager in place. That was according to 2 releases ago. So when you're doing tests with like kind, we're going to fake it. If you were installing to a cluster for real in the production world, one would expect that you have that already in place. The other thing that I'm going to do is I'm going to add a -w at the end, and all that's going to say is when you initialize the cluster, wait until it's done and ready. So here you can see that I said KUDO init. It's installing CRDs, it's installing namespaces, it's installing the service accounts, webhooks, and all the things that it needs. And because it now has returned 8 seconds later, we know that it is running. And what that means is that this should be there, right? If we went in there and did a get pods for the namespace of KUDO, there it is right there. Let's not dump it out in YAML, let's just look at it. You can see that it's running. And if we check the state of that, of course, the status already says it's running, but if we looked at the YAML, this would pass. So we have kind of what we're looking for. So now we have Kudo running. In fact, I can do some certain things because we added the CRDs. I could say, give me a list of instances. And so I don't have any, but I have a new type, right? That type didn't exist before. Had I checked that prior, that would have failed with, I don't know what you're talking about. So we have this new thing called instances. Frankly, we also have kget operator version. So there's none of them. But like if I did a get blah, right, it's going to say, I don't know what you're talking about. So we have two newly added things, which is what a CRD does. And for Kudo, we have four different types of new kinds added to the system. And I could actually ask Kudo that, right? If you haven't picked up on it, I have K alias for me because I just use it all the time. But so I have K Kudo get instance, and again, that doesn't, nothing exists yet. Oh, instances, sorry. And I just have a dot. That's all I have. Why don't we try running Kudo or Cuddle though? So Cuddle is going to actually do the installation. Let's walk through what it's going to do real quick. It's going to create a namespace as we talked about. It's going to do an installation of Spark. It's going to, once Spark is in place, then we'll have a new kind of thing there. In fact, this assert here will verify, that's not it. We install. We'll have a new, what is it, a Spark application type that's applied. So there's a new CRD even added with this operator. And then we'll verify that that exists. There's that Spark application I was referring to. And then we'll actually submit a job. So this is Cuddle applying something. We could just define the YAML completely here. The only reason I didn't was to show off that this is possible and to have a full working example of what a Spark job looks like. But if you had a YAML, like in this case, that you needed to either assert or to apply multiple times with Cuddle, well then, frankly, I could also say right here that I have an HTTP : / whatever your server is. I can actually pull a manifest file from a URL. That's fully possible now as well. That was one of the last things I added was, of course, I had to have that, right? How do you have a distributed system without the ability to distribute? So this will confirm on the assert that this was completed. It'll make sure that the event happened, and then it just goes through to delete and clean up. The only thing I didn't show you was this, the actual Spark job. I'm not confident that, I don't want to teach Spark. I don't think we have time for that. So hopefully you go off faith that of what Spark does, but all it is somewhat of the latest and greatest in the MapReduce space. We're doing analytics, right? And so there's going to be a number of jobs that spin up different activities and then consolidate answers into one resolved answer. And what else? This works by default. This is controlled, but this will be the service account that will be created by the Kudo's Spark operator once it's installed, if we didn't change it. So let's do that. We're going to say Cuddle. This is the full thing here. We can go ahead and delete on the process. But K Cuddle tests, Spark tests, and boom. It's going to run through. It's going to hit our current local environment that I have set up on Kind. It's now installing Spark. If we went, let me leave that on screen. If we go in there and say get Spark applications, you'll see that there's nothing there yet because it's just not ready, but it knows what we're talking about. That's another important thing. We could say CRDs if you like, and see that we have a newly added scheduled Spark applications as well as Spark applications. So, and now Cuddle is running through and doing its job. Unfortunately, this can take 5 minutes. So or 3 to 5 minutes is historically what it's done. So we'll probably pause for questions or continue through presentations and return to it. As far as Kudo is concerned, Kudo is now newly introduced to the sandbox for CNCF. Super excited, but awesome stuff. We have, from the very beginning, used a KEP process. Unfortunately, KEP has usually meant Kubernetes enhancement process, and we have a reduced version of that. We call it the Kudo enhancement process. It is almost exactly the same. It's just it's just shortened for things that we don't need. Like we don't have work groups, we don't have SIGs, we don't have any of that. But other than that, almost any major feature that we have added into Kudo is in some KEP, and you can research the decisions in that process or be a part of it. And we would love any involvement. From a community standpoint, we meet twice a month with a Zoom, with an open agenda. You can bring anything to it. We would love to hear from people in the community about where we could go with Kudo. Let's see here. I'm showing off the test harness. I should mention Justin, because not only is Justin awesome, he actually was the brain behind starting what is Cuddle now. He is also one of the major engineers behind Dispatch. So kudos to him. A little bit of tongue in cheek there. What I didn't show you is that Kudo, the CLI, can actually create on the fly the start of your operator. So I could say Kudo package create and foo. Oh, did I say this right? Maybe I might have typed it wrong. Yeah. Oh, that's for creating the package, not for actually creating the operator. Okay, so yeah, it's been a little while, I guess, since I've done that. But once you have a package that you have created, so all aspects of like the operator developer experience are automated. I can create the skeleton of the operator. I can add parameters from the CLI. Of course, you can do it by hand if you like, but there's also some verifications that happen. So I could say Kudo package verify. And in this case, let's go to Spark maybe. Yep. Oh, I must not be in the right package, or that might be my whole problem actually. Let me jump to the operator and say Kudo package create, maybe verify repo. Losing my ability here. All right. Place operators. How about this? Spark operator. Thank you. All right. So that was a lot to show you that it's verified, but verification, what does that mean? It means that all named parameters are actually used in some way. It means that I don't have a manifest file that's not used in some way. You could get warnings or errors depending on whether it's usable or not. And when we say package create, it basically does something similar, right? It will do the verification process before even doing the create. So that's kind of a walkthrough. That's probably more than I normally go through in talking about Kudo, but the whole process of being able to create the Kudo packages, or even, let's get more help, even creating the repository itself. I could either list the repositories I'm working with, I can create a whole new repository, I can create a new repository based on an existing repository of operators, and partly what that enables us to do is for people to have their own private repository, but also to work on-prem only in a air-gapped environment. So that it takes more to be air-gapped aware than that, right? You have to know that the operator that you're using is available locally, and you have to know that the resources that are being pulled down are not pulling from other places. So there's a lot more to that, but just be aware that we are part of a solution there. What else?
So I have a question.
Please.
What did people do before Kudo for testing and things like that, for operator testing and packaging?
Okay, so now we're talking about Cuddle in that case for testing. And let me see here. So the short answer, until I find what I really want to show you, is that people tend to use whatever they could. And what it typically meant is they either use Bash, because it's very common for a DevOps person or a very ops-oriented person to be kind of Linux and Bash-centric, or at least script-centric. So that's what we end up seeing in the Kubernetes proper. We also see people using Python. So those would probably be the two primaries. You could also go out. I'm sure there's more, probably more than I'm voicing right now. If you went out, there is a testing sig now, and I'm assuming that they have even more than the things that we talked about. With that said, I just recently did a presentation last month to the SIG testing and got some pretty great responses from them. So we'll see. This is really new, like pulling it out and separating it, making sure that it's available is really, really new stuff. So
Yeah,
I'm showing you right now what's available in Kubernetes proper, right? Like, I don't know if the zoom in works while we're on Zoom, but this is the crd.sh. This is in the test folders for Kubernetes in Kubernetes proper. Oh, I can't zoom out. That's great. Okay, whew, that was close. And my machine's acting a little funny, so I apologize. But point is that this is how they assert things. And I would love to be a part of helping to swap this out to something that looks more like this.
I see.
You know, like that. This is very clear what's happening. It's clear. Hopefully it's clear. People have been picking it up fairly quickly and understanding it, but
it's more
and there's still
structured.
something. Yeah. It's what you're expecting, right? You are used to using manifests. You understand what the manifest, and frankly, when you're at the command line and you say, I don't know, get the pods, and you do a YAML output, that's what I'm used to seeing. This is the exact thing I'm used to seeing. So frankly, I could take a dump of this, modify this, and then call it an assert, and I'm done. Assuming you take out, IPs and times and things of that nature.
Yeah. Okay, and then from KUDO's perspective, like what are some alternatives?
Oh, KUDO. Okay, yeah. So KUDO is all about. Let me answer the question. If you look at KUDO strictly as for building out operators, then your alternatives are a do-it-yourself against a RESTful API, meaning at that point you could use Java or some other language or Python. It wouldn't matter. If you're going to build anything mature, I don't know of anything mature outside of the Go space, and it might be what I'm exposed to. So I have to be careful about that comment, right? But most of what I see as an alternative would either be Operator SDK or Cube Builder. Both of those you would have to know a lot of Go. And as you saw, I could show you a number of operators, none of them have Go. So, that's the case. If you're looking at from an orchestration of microservice-based architectures, I don't know of anything, unfortunately. Whether something exists, I'm unaware of it. We've been talking lately about taking that component of mapping plans, which currently we have within kind of the core of KUDO, and potentially even applying that on other objects. So what if someone installs something with Helm, but they want a plan to it? They want to organize it in some way. I'm daydreaming at this point. It's super early, but the idea of being able to manage the orchestration of something and build some intelligence into how something should be provisioned or repaired is useful, I hope.
Yeah, that is interesting.
Yeah, so that I think we're pretty much through it unless people have questions. We did recently add diagnostic bundles, so that should be there. We're currently hooking in metrics. What else is there? We just added last month the ability to have dependencies. So I can have like Kafka dependent on Zookeeper, and it will install all the things. We need more feedback on that. Right now, all the things are installed to the same namespace. So there are certain limitations, but that's only because no one's told us otherwise. We don't have use cases outside of that. And one would expect, this is a reasonable default at this point until someone says we want something different. We've been fairly rapid at being able to build out new features. So Our cadence currently, we have a release every month, roughly. It varies, of course, in the size by what features are ready to be landed, but we tend to have a release the first of the month. And with that, here's how to get in touch. The team is always on Slack on K8s. We have kudo.dev and cuddle.dev if you're wanting to get in the test side of things. And of course, everything Kudo Builder is our location. And under that, you're going to find Kudo and Cuddle and the operators and a variety of tools and such. Cool.
You're on mute again. There, it's like, oh.
Is this better? Yeah. Yeah, okay. That was good. Thank you. Thank you, Ken.
Welcome.
Yeah.